Welcome to Cascadeur. You are currently looking at the Start window. You can open it by clicking the Home button. Here you can see your most recent scenes. In our case, this is the first launch of the program, so there are no scenes yet. And these are autosaves. And in this tab, you can find scenes with the pre-made characters. Let's open one of them. Here you can see the character in the viewport. By the way, their name is Cassie. Let's rotate the viewport camera to take a closer look. Hold the Alt key to control the camera. Alt plus the right mouse key controls zooming. You can also zoom by scrolling the mouse wheel. Alt plus held down mouse wheel will move you around. Alt plus the left mouse key is rotation. You can also click on the axis arrows next to the view cube to snap the camera view precisely to the axis. And clicking the center of the view cube toggles between isometric and perspective modes. In this corner of the viewport, you can find all the view modes options. Each view mode displays only specific types of objects, which helps eliminate unnecessary visual clutter. For most cases, you will primarily need the first two modes: View mode for viewing animations, and Auto Posing mode for controlling the character's pose. To edit a pose, select a controller, then move it using the manipulator tool. You can move an object precisely along the axis arrows, along specific planes, or within the plane of the screen. This button allows you to switch the manipulator's orientation to local mode. In this mode, the direction of the axis aligns with the axis of the selected object. And in global mode, the manipulator's axis aligns with the scene's axis. Now, let's take a closer look at how auto-posing works. By moving the control points, you generate a query for the neural network. As soon as you move a specific controller, you effectively include it in that query. Such a controller is referred to as an active controller, and it is highlighted in blue. Inactive controllers are highlighted in green, and they constantly adjust their position to match the active controllers. For example, this wrist is currently moving in sync with this one. However, if I activate the wrist's control point, it will stop adjusting and remain fixed in place. To deactivate a point, you can use this button. When you do so, the controller will immediately revert to its default position as determined by the active controllers. Alternatively, to deactivate a point, you can use the hotkey Shift+Z. Sometimes it's easier to select multiple controllers at once. You can do this by using a selection box. If the box encompasses any active controllers, only those specific controllers will be selected. However, if all the controllers within the box are inactive, then all of the controllers will be selected. Now let's rotate our character using the rotation manipulator. You can select it from the toolbar or by using the hotkey E. You can change the rotation pivot point by right-clicking on any controller. Another way to select multiple points is to hold down the Shift key. Hold down Shift to add points to your current selection or to remove them from it. You can quickly jump between the rotation and movement manipulators using the hotkeys E and W. You can learn more advanced posing techniques in a separate tutorial. Typically, with some practice, you'll be able to set up poses in a matter of seconds. If you have your own model you'd like to work with, you will need to create these rig controllers. I'll show you how you can quickly create them for a humanoid model. And then, let's create an animation. If you don't have your own model, you can skip this section and continue working with Cassie instead. But if you do have a model, please open a new scene and use the File menu to import your model into the scene. The model must be in a T-pose or A-pose and feature a joint-based skeleton with a mesh. Immediately after importing the model, Cascadeur will prompt you to switch to rigging mode. It will also give you the option to enable a quick rigging tool. Since my skeleton was not fully recognized, I will have to assign the controllers manually. On the diagram, you can see that only 3 controllers have been assigned so far. To assign the remaining ones, I need to drag the joint names onto the corresponding points in the diagram. For the limbs, this only needs to be done for one side, either the left or the right. Next, I need to assign the finger controllers for the same side. If your model lacks the specific joints required for certain controllers, you can simply skip them. However, in such cases, the auto-posing feature may not function correctly. If your model includes joint twists, you can configure them in this tab. My model, however, does not have any twists. I can now mirror the rig controllers to generate them for the opposite side. To do this, I need to enter the specific side identifiers exactly as they are named within your model's joints. I then click the mirror button and I see that all the points in the diagram are now populated. You can add the rigging elements to the model. All the rigging elements have now appeared in the viewport. I can now generate the rig and switch back to animation mode. I recommend saving the scene with the completed rig controllers right away. Later on, you can simply open the scene to start a new animation, avoiding the need to recreate the rig controllers from scratch every time. Now, let's get to the animation. I am currently at frame 0. Let's set our first pose here. I want my character to be simply standing. However, I don't particularly like the arms here, so I'm going to adjust them slightly. Now, let's create a new keyframe at frame 60 using this button. Navigate to the final keyframe and select the character's center of mass. That's the point located right here in the center. Slightly move your character to the side, approximately to the next grid. Now we have two keyframes. In the first one, the character is here, and in the second one here. Select any frame situated between these two keyframes and apply AI interpolation to the interval. The frames between the keys will immediately change color to match the selected interpolation mode. Let's switch back to frame 0, enable view mode, and see what the animation looks like so far. As you can see, the AI has generated a walking motion between the two keyframes. Let's make this a little more interesting. Select a frame located roughly halfway through the stride and create a new keyframe here. Now switch back to auto-posing mode and edit the character's pose at the specific keyframe. I want to add a jump here. Now I can make some minor adjustments to the pose to make it look more convincingly like a jump. Here, I can enable the automatic locking of the auto-posing points to ensure the new pose remains as close as possible to the original one. During editing, I will deactivate some points so it's easier for me to control the limbs. Let's take a look at the results now. The jumping motion has now been created between the two positions, as the AI interpolation has taken into account the new poses we just created. This way, you can gradually refine your animation by continuously adding new poses. For now, let's take a look at how the physics work. Physical duplicate of the character has now appeared alongside the original. On the physics ghost, you can see what the animation looks like after applying the physics settings. Sometimes the changes aren't immediately obvious. Open the Physics Settings tab. Click here to overlay the physics copy directly on top of the original animation. This allows you to examine even the slightest adjustments in detail. In posing mode, you can reposition the physics copy wherever is most convenient for you. You can also view the fulcrum point directly in the viewport. In frames where the points are touching the ground, they are highlighted in green. You will also see a bar above the timeline. When both feet are planted on the ground, the bar is dark green. When one leg is lifted, the bar is light green. And during the jump, where both legs are lifted, the bar is orange. The physics filters are located here. By adjusting these filters, you control the intensity of various physics parameters. For example, if you increase the smooth trajectory value, the character will squirt more deeply both before and after a jump. And the secondary motion filter allows you to fine-tune the arm's movement. By default, the filters are configured to suit most animations. Therefore, for this particular example, you likely won't need to make any drastic changes. Now, let's apply these physics adjustments to our animation. I recommend saving your scene before proceeding so that you can later experiment with different settings and compare the results. Before applying physics, press this button. This ensures that the changes are saved for every single frame. Now press this button to transfer the physics changes from the ghost to your character. You will see a warning pop up indicating that the physics filters will be reset to their default settings. Click Yes, and you will see that your character now perfectly matches the physics ghost. Now you can disable the physics ghost. The color of the frames between the keyframes has changed. The green color indicates fixed interpolation, which means that the changes have been saved individually for each frame. This type of animation is called baked animation. Now let's add some textures so we can make it even better. Switch to Mesh mode, select the mesh, and then open the Material tab in Object Properties. Here you can upload your textures maps. You can also add an HDRI environment map in the Scene Settings tab. And using this slicer, you can rotate the map. Now the scene looks much better. The animation is ready. You can now export this animation as a video file or as an FBX to continue working with it later. For example, if you want to integrate it into your game. That's all for today. Thanks for watching, and I'll see you in the next video.